Right.
And
So yeah, we're all set now, I guess.
yes, I just started the YouTube live, but I think quite some people may be still joining. So let's wait for maybe 3-4 minutes.
Yeah, no problem.
Yes. So I will. So first, I will start with an introduction, and I will have a short talk, and then I will hand it over to you.
Sure.
Okay.
So how long do I have? Like maybe 20-30 minutes?
Your talk will be 20-30 minutes, but mine will just be like 10 minutes.
Okay.
Yeah. Yeah. So yeah, if you want, you can also not share the screen now, because I will share mine. But moment. Let me.
So are you in Simpak right now in Fugawat?
Yes. Yes, I know you work here before.
Yeah, I've been there doing my master's study. Yeah.
Very
quite a beautiful place. Yeah.
Very nice. And now where are you?
I'm back home in China. Yeah.
Okay. 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 So hi everyone. I think there are still a few people signing in right now, so I will wait for another 2 minutes or so. Yeah. Oh, sorry, I was muted. Hello, everyone. I think now most people who is coming have logged in. So hi, everyone. Good morning or good afternoon or good evening, depends on where you are. I'm Jenny Chen, and I'm happy to host this webinar today. First, I will give a short introduction, and also today I will give a short talk, and then we will have our speaker as talk. So let me share my screen here. I think it's this one. Yes. Okay. So first, I will give short presentation on some highlights of recent papers published about tracking shorebirds in the East Asian-Australasian Flyway, and some resources for data analysis. So it's almost the end of the year now, and yeah, it will be nice to have a recap of what has been published in this area this year. But first, I will talk a little bit about some new things about the data analysis comes out that I know of. Of course, maybe you know more, and feel free to post something in the chat to share for everyone. But this is just a little bit of what I heard recently. Last year, around this time last year, we have a Move Apps workshop that show how it works. And now I just want to mention that Move Apps has developed further. So Move Apps is a no-code platform to do some movement visualization or simple analysis. So you people can. So if you use the apps on the existing platform, you can just drag and drop and run your data through this pipeline to, for example, make a map or something like that. But if you are quite good in programming, you can also write your own little apps, like your own functions to make a map and share with everyone to use. So I encourage you to look into it. And if you want a recording of the workshop last year, I can also just email trackeaaf@gmail.com, and the email will show at the end of the presentation, and I can share with you. And then there's also recently, there's a summer school called AnyMove. It's quite a well-known summer school on animal movements that is held every 2 years or every year even. Yeah, I think it's every year. But unfortunately, it was cancelled the last 2 years due to the COVID situation. But it was again this year, and they are uploading their online lectures and notes. So they say it should be online in November, but today I haven't seen it yet, but I think it will be up soon on this website. So I encourage you, if you are interested to learn more about analysis techniques and the newest methods out there, really, there will be a nice resource to check out. And if you want to keep track of all the new updates on our packages analyzing tracking data, there's a page on the craneRproject.org that you can follow. And there's some new methods coming out that I find quite interesting. For example, we all now, there are more and more people, we try to infer species distribution models from tracking data, infer species distribution from tracking data, but of course there is some bias, like because you didn't, like most of us couldn't track most of the individuals of the population, of course, and it's only a very small proportion, and maybe we only take birds from one location or not that many locations, and there will be a bias. So this paper here, quantifying effects of tracking data bias on species distribution models, discuss like how these different sources will introduce a bias on species distribution models and what is important, what is not. So check it out. And so there's another package that came out to identify important sites for biodiversity. So basically they use some, they will identify places where the many tracked birds congregate, and this looks very promising, and have a look as well. And thirdly, so there's also a related issue on sample size. So if we want to look at distribution analysis, it's always a question if our sample size really is enough to show the distribution. And this paper by Shimada et al. Also discuss what would be the sample size, and also you can do analysis after you collect your data to see if your sample size is good enough, or maybe you will need track more birds to actually show the actual distribution. So they look at overlaps between tracked birds to see if you're to understand like if the sample size is good enough. And then now so that's all about the methods that I gathered. It's quite short, but yeah, if you know about something new, please feel free to share it in the chat with everyone if you want. So now go to the parts that I highlight some papers that recently published about tracking shorebirds in this flyway. And I'm really excited about this because it turns out to be quite a lot. And so first, there's a very recent paper came out on annual routines and stopover sites of pied appleset that breed in Bohai Bay in China, by Wu et al. And they actually show a very interesting result that so the red is where they tag the birds, but there's very important stopover sites at Lianyungang. So that's a really important message for the conservation of this important shorebird area. So, and then another paper that also came out quite recently shows the migration network of several Dunlin subspecies in this flyway. So this is a very nice one of the graphs from the paper, and and it's really nice information on the different subspecies. And a paper a bit further back, also published this year, is on the non-breeding region and migration routes of Whimbrels by Quan et al. So also showing these migration routes and birds to these two breeding areas. And so please take a look. And then we have paper on black-tailed godwits on current breeding distribution as known from tracking data, but also how a range shift is predicted under climate change. So they looked also at two subspecies of birds, and that's a very interesting paper. And then there's another paper on Far Eastern curlew. So they check the population trends. So they first track the birds from Southeast Australia and also Northwest Australia, and then they try to link the connectivity of these two populations to the
Josie.
And oh, sorry. And they also found that there's also a link to the amount of human impact at the distribution of these different populations. So it's quite interesting study. That's on Far Eastern curlew, if I haven't mentioned it. So yeah, so, oh, and then lastly, I almost forgot about this. I also have a paper published recently on the migration routes of one subspecies of the bar-tailed godwit, as shown by satellite tracking. So that's the Anadyr subspecies, and so that's the orange routes here. And I compared that with the Mansbury subspecies, that's the blue ones, and I really show that they have different stopover strategies and different timing of migration. So please take a look. So, and there's, I think that was all on really tracking shorebirds with a tag. But there is also a few other papers I want to mention that is about using other methods to understand distributions, for example, like this one, look at bar-tailed godwit distribution of the two subspecies happening in Asia. So they use ranging data. So and then they have they know that these two subspecies differ in the morphology. So one is bigger basically, and then they use it to look through ring data from all over the flyway and try to infer the proportion of the subspecies in each place. So that's really interesting. So for example, in this graph, there is MIPO, and then it shows this Ohio and Melanurottus. So how many birds belong to which subspecies in spring, autumn, and winter. So feel free to take a look. And there's also another one on more on the conservation side, exploring risk and benefits of flexibility in biodiversity offset location in a case study on migratory shorebirds. So this is a more paper more on the application of tracking data. Yeah, take a look. And okay, so and there's another paper that is more about what is more like it's not presenting new data, but it's raised some questions that is raised by past studies. So there was a lot of so not only in the East Asian-Australasian Flyway, but also there's actually this, we can call it like a flyway in the Pacific, that a lot of different species are crossing that, and a lot of shorebird species are making these really extremely long flights, and it really raises questions on, for example, what is the physiological limit of bird flight, and how these really long, extreme long distance migration, how this migration evolved. So if you want some more inspiration, this will be a nice paper to read. And there's also a paper by Wang and colleagues on impact of habitat loss on shorebird populations and communities at stopover sites in the Yellow Sea. So this is based on counts data, but it's really, really interesting paper showing how current situations compare to the past. And so, well, it's already like the last one, and of course it's the paper published recently by our next speaker, Xu on using weather radar to track to understand bird migration. And yeah, I won't talk anything more about that because she will. And so here I will introduce our next speaker, Xu. He's a PhD student from the University of Queensland. And please, thanks a lot for coming. And okay, so yeah, hi. So yeah, please. Thanks for coming, and yeah, you can start if you're ready.
All right, so yeah, thanks a lot for getting to invite and introduce me, and I'm very glad for the opportunity to present my study to this very dynamic and productive group, the Shorebird tracking group. And so I'll start sharing my screen right now. So is it in full screen now? Can you see it?
Yeah. Now, yes.
All right, so yeah, as Gillian just introduced, I'm a PhD student now in the University of Queensland and Exeter, doing using weather radar to study bird migration in general. And what's interesting is actually we started this project working on shorebirds actually with the Australian radars, and during the process we just realized why not work it on all the birds. And so here we are. We start with this paper on the potential and the prospects on using weather radar to study birds from the whole East Asian-Australasian Flyway, especially not just the shorebirds but some birds as well. So today I'm going to talk about how it actually works using radar to study birds, methods, and the prospects. And I would also give two case studies, one from China and one from Australia, how to quantify the large-scale bird movement. And eventually I would talk about some of the opportunities that I think may be useful or helpful for the shorebird people if they want to use radar for their research. And if there's any questions, you can just let me know, and I'm happy to answer it during the talk. All right. So as ornithologists, we are really interested in the bird migration, and every year there's just billions of birds flying across the globe. They transport a lot of nutrient, energy, and pathogens. They provide a huge amount of ecosystem services, and their movement are also sometimes highly relevant to human welfare. Which is why it's very important to protect to understand the bird movement, to conserve the biodiversity and safeguard the ecosystem service that they provide, and reduce the human-wildlife conflict when it's necessary. So to achieve these goals, we are now increasingly in need of large-scale monitoring and quantification at sometimes like ecosystem levels, and especially near real-time surveillance of forecast of the bird movements. So as of today, the most common ways to study bird migration would be such as raining and GPS tracking or manual counting. These methods have really greatly advanced our understanding of the bird migration, but it's also these methods are sometimes we know they are either labor intensive, or it only involves limited number of individuals, or it can be very costly. And if we want to answer like really large scale questions, we want to upgrade our understanding of the ecosystem, of the migration system, from organism level to ecosystem level, from species to community, from like regional scale to broader, even continental scale. How can we achieve this? Is there a method that is ideally like low cost and low requirement for manual effort? Hopefully it's all automatic, would this too good to be true? Well, just like satellite is continuously serving the land for us, weather radar in the world is continuously serving the airspace for us. There's lots of weather radar already installed in all parts of the world, especially in the global north. As we can see from this map, the lighted illuminated area are the weather radar coverages. So radars, they detect things in the airspace, such as precipitation, snow, and by transmitting transmitting echoes and receiving the return echoes. They can also detect birds, bats, insects, anything that flies in a similar manner. So it's mostly easy to show you on an example. So here's a EAAF created from the Brisbane radar in Australia. And this is what it usually looks like on the radar image, that we have things in the air as shown in this reflectivity colors on the map. Here we can see that there are lots of purple and red, and in general, like really high reflectivity. We really call it the DBZ values in the radar terms. This is usually the precipitation or other weather phenomena, and we can let the radar loops run. We can see that there's probably a rain event or weather front passing through Brisbane, and this is in the afternoon before sunset. So, and immediately after the sunset, there's something really interesting happening in the atmosphere. We can see that the airspace is suddenly full of like this emerging, fastly moving dynamic signals. These are most likely biological, whether it's birds, bats, or insects. But we can see the difference between them and the slow-moving, relatively high signals of precipitation. And this is from the Brisbane radar. We can also look at we can also find similar pattern in more large-scale networks. I'll share this from the Chinese radar network. So the Chinese Meteorological Organization have their radar maps online. And sorry, for some reason, it doesn't really work on my computer, and we can only see parts of China, but I think it's enough. So let's go back to not today, because the migration's already ended. So let's go back to July and September, and pick one day, and we start the radar loop from before sunset. All right, so we start from 18 o'clock. So we can see that there are some signals above China right now. These are probably precipitation. And note that immediately after sunset, there's huge amount of stuff emerging into the sky, following the sunset line from the east to west. We can see them from all the radars in eastern China and from the northeast China all the way to the south. So, and these are the signals that we can see them during migration period and not other times. For example, I changed this period to July, and which is made up. There's a lot of rain, so let's take another day, and we do the same thing. We let the clock run, and again there's a lot of precipitation in northeast China, like here, and some here. But you can see as the night progresses, there's not much signal, that not much thing that is happening in the air. So, and which further is the evidence that what we are seeing during migration is there are some, but not on the same scale as what we are seeing during migration season. So that would mostly be birds migrating in the sky during the night, and mostly passerines. So yeah, and this is just two examples of the raw radar data that we can see every day, and what is happening in the air. And but the center for radar study is really the Europe and North America. We have been able to describe. People have been publishing lots of stuff on how to use radar to detect and quantify bird movements. We can study their direction and intensity of the bird movement, the seasonal biomass flow in and out of Europe, and make continental-wide forecast of bird migration, like this map from the Cornell lab of ornithologists shows. So one thing is, so far, most of the radar studies are coming from Europe and North America. What's happening here in East Asia, in Australia, you can see that there are lots of radars, but so far the studies using weather radar to study bird movement is extremely rare. And especially we know that this part of the world is home to the EAAF, which is one of the most species-rich as well as endangered flyway. So it's weather radar could really be of great potential in this area. Hence, we ask some very simple research questions. How many radars are there in the EAF? How well do they cover bird migration? And what we did is simply collect the radar information from all these EAF countries and overlap with them with the species distribution maps. For example, using the Siberian ruby-throat, we can see that. So from the data set are from the BirdLife International that are separated into the breeding season, non-breeding season during passage. Well, we found that there's a large network of radar exists in the East Asia all the way to Australia, about more than 400 radars, and in China alone there's more than 200 radars, and they cover for each radar they could cover a high number of migrating birds, especially the radars in the south and southeast of China. So the richness is highest per radar over there. We also compared the potential radar coverage for different group of birds during different seasons, and we found that radar is able to provide coverage in most of the seasons, especially during migration and in their non-breeding range. For breeding season, it's a bit low because we can see again from the ruby-throat example that there are only few radars in their breeding zone, but during their passage and in their wintering area, radar is able to provide like a large area, a large portion of their habitat, coverage of their habitat. So, and therefore the whole networking in the flyway is able to provide nearly complete coverage throughout the year for many migrating songbirds and water birds and potentially shorebirds as well. What could be very interesting to this group is we also compare like how many important shorebird sites are close to radar. We found that these sites are from a 2014 publication from the WWF. We found that there are about 70% of all the sites shown here are within 100 kilometers of radar, and about half of them are within 50 kilometers of radar. So the closer to the radar, the more likely that the flight is going to be picked up by the radar, because the further away you have and lower down, it won't be picked up by the radar. And it could be, well, lots of potential for shorebird monitoring using weather radar, and I will talk about this in more detail later on. And well, still at this point, we're simply evaluating the potential, and for us ornithologists, it's only satisfying to at least see some results, right? So we gathered data from 55 radars in October from China, and we used well, some deep learning methods to get the bird signal, our biological signals out of it, and discard the weather signals. So what we found was very interesting. first of all, the bird migration directions are rather uniform, and as expected, that's during autumn, most of them are flying southwest, so they're going to winter in South China and Southeast Asia, which is not very surprising. But what could be very interesting to ornithologists and bird watchers as well is we think that the peak of the signals are coming from the central parts of China, and the coastal parts are relatively low in terms of bird density. In China, because the coastal provinces are, let's say, more economically developed and there are more birds there, so most of the bird watching and research are done in the coast. However, in the central part of China, like in this part of China, there's very few like complete surveys and records or tracking studies. So and yet our studies show that it could be the highest amount of migrating birds are in China. So, and more surveys or simply bird watching in the future could really help to complete the image, our knowledge of bird migration in China, if they're coming from the central part of China. So, and the results above are just being published online, and yeah, and we're glad that we're able to push forward using weather radar in this region to study bird migration. So what we've shown here is just like 1 month from China, and especially that in China the weather radar data is not really open access. So we have to rely on somebody who has the access to help us do this research. However, in the other end of the EAAF in Australia, there's also a large network of radar available, and most importantly, they are all open access. So you can just download and play with it anytime you want from your own computer. What we did is we want to paint, like for the first time, a rather complete picture of the bird movement patterns in Eastern Australia. So what we have are the raw data, as I've shown you before, and we use our package called BioRad. It's specially designed to analyze bird movement from weather radar. We can extract the bird density in the air throughout the time and on the vertical plane as well. And by doing this for every day for the last 4 years, we can get a measurement of reflectivity, which is not exactly a number of birds, but let's say a radar measurement of how many stuff are there in the sky. And we can see that for Brisbane, for this radar in Brisbane, throughout the year there's 2 apparent peaks, one in autumn of Australia and the other in spring. So it's like what you would expect for a typical migration scenario, that there are more movements in autumn and compared to spring. So but this is the radar measurement of reflectivity. It's not yet the number of birds, and honestly, because radar cannot tell you what species it is, right? It can only give you a measurement of how many things are in the sky, and so how do we infer what species are flying out there? We took it to the eBird data. So we used 4 sites from Australia that has a advanced weather radar, and also that are home to the highest amount of eBird recordings in Australia. So we want to compare the eBird trend is rather comparable to the radar trend, and what species could be potentially migrating out there, inferred from the eBird data. And we modeled the species abundance throughout the year. So for Australia, we took here's some typical birds for Brisbane in Australia, that there are like this monarch, which is for non-Australian birds, it's something like a flycatcher, so behaves like that. So, and it's a summer breeder, and passage passing by in Brisbane, so we see the two nice peaks throughout the year in spring and autumn. And the dollar bird here is a summer visitor in Australia, so we say the abundance is rather high in the end of the year, and but non-existent in the middle of the year. On the contrary, the rose robin, really cute bird, it's a winter visitor in Australia, so we see that its relative abundance increase in the middle of the year. And the fairy birds are resident, so their abundance doesn't really change throughout the year. So we did this for a huge range of birds, and we sum them up and compare with the change in radar reflectivity. We found that the eBird abundance change and the radar reflectivity, amazingly, they match really well for example, for Sydney. Right? This is way better than what we expected, actually. And for Brisbane, for Melbourne, there's also some good agreement between these two very different, not related at all measurements. Although for Cairns, it's not that good, but it could be that the Cairns radar is a bit high in elevation, and that's why it doesn't really capture the migration in the lowlands. So and we did this for all the radars along the East Coast, and we found that there are typical, well, could be typical migration patterns throughout the year for many radars, and their movement peaks. So like the peak here and the peak here follows a latitudinal gradient that we would expect throughout the year. So for the southern side, like in Tasmania and Melbourne, the peak passage date is earlier, and for Brisbane and for Cairns, it's later in autumn. But this is, we are still working on to improve this, but it actually gives us an evaluation of how many birds are there in the sky, potentially migrating for Australia. Because although we really know the migration scenarios and species assemblage really well in Europe and in North America, but such knowledge is still rather missing for Australia, and we don't really know whether there is a significant amount of seasonal movements along the East Coast. We know there are some, and many of them are probably also nomadic or opportunistic movement, but we hope we can show that there is actually a lot of birds migrating in Australia as well, just like their northern hemisphere counterparts. So, and the results that I've shown so far are doesn't discriminate between bird groups, so, and weather radar counts, so it's all birds combined. And as I would say, in this case, it's mostly passerines or freshwater birds. So, and shorebirds are probably not that many, because it's all, I forgot to mention that it is all a nocturnal signal. So shorebirds is probably not a big part in this. So would it be possible to use weather radar to study whether it's the shorebirds, like whether is it the flight, the movement pattern, the day pattern, or to give an estimate of the shorebirds populations? There's only a very few shorebird study with radar, not just weather radar, all kinds of radar. There's only a very few studies, and but I think it's there's definitely a possibility, because I can show us some examples, because although we can't tell what's animal or species of birds are flying in the sky, but when there's many of them and they show a large congregation, we are able to tell that. So, for example, the flying foxes are large-bodied like bats in Australia. They often form roosts of hundreds of thousands or tens of thousands of individuals in some sites, and their signals are when they depart from their roost after sunset to forage, we can readily see them on the radar data. So here's a set of image from, again, this is from also from site in Queensland in Australia. So I'll just play it and you can see what's changing. So but we can pay attention to this Torquay site, and we can see that after sunset there's some really high signals emerging from this part of the bay, and they are moving more inland, and you can see here and here as well, and the signal diminishes after about an hour. This is typical the departure from roosts of these flying foxes, and where people have been able to estimate the number of birds by translating the radar measurements to the density and number of the flying foxes. So, and it's also possible to do this on large number of birds if they are flying at once and form a very strong signal, such as the magpie is in Australia as well. Studies have shown that the radar signals are in high agreement with aerial service. The radar signals are from the left and the aerial survey hotspots are from the right. So there's a high agreement of where this large number of magpie groups are. It's also sometimes very visible movement on the weather radar signal, such as the purple martins from North America, that they form these beautiful rings when they depart from their roost early in the morning. So the point is, if there's a large congregation of a species and they fly to the air, we can possibly see it on weather radar and be certain that they are a species or category of species. So I think that's a possibility for shorebirds. And talking about a large congregation of potential shorebirds and major shorebird roosting sites, one site is I think is particularly interesting if you want to do such studies, is the Broome in Australia. Every year, I think people in this shorebird tracking group are probably more familiar with this site than me. I have never been there. I really wish to visit this place sometime. That there are more than 100,000 of shorebirds wintering in this region, and they arrive here and depart from here every year. So I did found one study like almost 40 years ago that they look at the weather radar. Sorry, well, there's one radar right in the center of this town here, and they use cameras to take time-lapse images from the radar, and they found that on the the peak of departure from this island in the middle of April, and in the afternoon, they can see that this dashed lines going from this direction is the time-lapse tracks of shorebird flocks seen from the radar. So, and they are able to identify individual flocks, when do they fly, the direction, the height of their flight. So, however, there's not much more studies after this one. But personally, I think it's definitely worth trying to, not only in Broome, but in other parts of the world where there's a large number of shorebirds roosting together, and whether it's their daily foraging flight or they're departing and arriving at this place, that's and especially when there's a weather radar nearby. So it's definitely worth trying to use radar to study their movement patterns. Maybe like, for example, not just Broome, but other parts in Australia as well, and on the east coast of China, such as Rudong and the Bohai Bay. It's all possible to see similar patterns from the radar network. I think it's there are several topics that I think would be possible to have a try on. First is the departure and arrival behavior of shorebirds, especially that in places where we don't have historical accounts of shorebird numbers. However, that weather radar sometimes the data are stored back in the 90s, for example, in Australia. So we have maybe 20 or even more years of radar data where there are no bird counts. So if you want to search back in the history of what the situation for the shorebirds in their war, maybe radar is probably the only accounts that still exists for that information. It also could be very useful for sites that are hard to access or it's difficult to organize people to do repeated visits, because radar always works and it's always there. Thanks, Danny, for the input. Yeah, and I know this one as well, but it doesn't have a like really nice picture, so I select the paper from Lei. Yeah, and also other studies are possible as well, such as detect where the birds are departing from, so you might know where they are roosting, and make estimates of their population size. So this is really a really new field, I would say, for shorebirds. Although there are maybe a couple historical studies, but using the latest radar technology and radar storages, maybe there's a lot more opportunities in this regard. That's my presentation today, and thanks a lot for listening, and I'm very happy to answer any questions if you have them. So,
Thank you very much for your very nice talk. Very interesting and information, and really look forward to more radar studies in this flyway on shorebirds, and also on other birds. So I just saw a message from David Melfield that he looked at migration over Hong Kong in the 70s using air traffic control radar. So he has a report that he shared. And
thanks a lot. I will have a look at this later. Very interesting. I think there are another study from Hong Kong in the 70s or even earlier. But you see that in the EAAF in East Asia and Australia, the radar studies are really like maybe 30, 40 years ago. So, but maybe it's time to do some new studies, I guess.
Yes, and there is like this migration bird alert in the North America, I think, that they use the radar information to really show where there's a peak in bird migration. Do you think this can be done in East Asia as well?
You mean doing the similar like predictions of migrating birds? Like
it's like a website or so. That's
birdcast, like
I think it's called birdcast.
It's definitely possible, and all we need is the radar data and the environmental data, such as the landscape characters, the weather, atmospheric information, and with some modeling, and it's definitely possible to do the same.
Okay. Oh yes, I see. Jimmy Choi has a question. Jimmy, please.
Thank you.
Hi, Jimmy.
Thanks a lot, Xu, for the interesting talk. Glad to see you here. You might have mentioned about this already. I might have missed it, but can the weather radar tells you how high the birds are flying?
That's one of the advantages of radar. I would say it can give you an estimate of the speed, direction, and the altitude of the target in the air. So definitely.
And how accurate that is?
Oh yeah. So for weather radars, it's probably not that accurate. Usually we categorize, like my study, I categorize them in about 200 meters. So like each altitude band is about 200 meters. But with the other radars, like the bird radar, specific bird radar we talked about before, it can give you a rather precise estimate.
Right. I was asking this question because there have been quite a bit of discussion on evaluating the impacts of wind farm, the wind turbines, to migratory birds, because there are now a lot of proposals in along the flyway actually about building more wind farms. And if weather radars can tell us how high the birds are flying, because you have already shown that we can monitor the movement of the birds. And if we can also monitor the heights of the birds, then we can potentially look at how wind turbines are affecting the birds, or how the birds are responding to this. And there may be quite a lot of potential and importance with doing such a study. And yeah, so it sounds encouraging. You said that the bird radar can give you a more precise estimate of the heights. So it's good to know. Yeah, thank you.
Yeah. Thanks for the question, Jimmy. And for the wind turbines, it's I think it's a rather active research front in Europe that they are using bird radars to study whether there's the collision risk, or whether there's like a displacement effect on the migrating birds. So it's definitely possible, but I'm not sure with weather radars, because it would be a case dependent thing. It has to be close to the radar and not blocked by the terrain. So I think specific design bird radar is really much better in this case. And I saw another question from Danny in the chat box. So Danny asked, is it possible to distinguish birds from insects with radar data? And and how much altitude information can we get? So that was hopefully that was answered. And as for the distinguishing birds from insects, it's part of the core challenges, and also big part of the algorithm that I'm using is to distinguish between the two. The general idea behind this is that birds are able. So we need Doppler radar for this, because with Doppler radar you can get the speed information from the target. And the basic idea is that birds are able to generate a more self-powered flight. So their flight is not really blown by the wind. On the other hand, the insects are. So, and the insects are, their movement are more homogeneous in terms of the direction and the variation in their speed. While for birds, it's more variable, and that's how, well, with some lots of statistics, you can give a confident classification of whether this is birds or insects.
Cool. Thanks. Are there other questions from the audience? Check. Also, David also mentioned that there's still some data from Hong Kong. Yeah. In the past. Yeah. So maybe you can contact David Malfield further if you're interested in this information.
Yeah, I remember this study that he mentioned. So yeah, it's one of the very few studies that is in the whole flyway actually. So.
Yeah, Chang asked what about migratory bats?
Yeah, very good question. This is troubling me for a while actually, because in Australia, especially, there's the flying foxes are moving everywhere, literally. What we are trying to do here is, and if there's a single flying fox compared to, for example, a single lapwing or similar sized birds, it's essentially impossible to distinguish them with the radar signals alone. What we are trying to do is trying to filter out the flying foxes by their flight altitude, because they mainly fly below 400 meters above ground. And when they do, they, as I showed before, they form a very strong signal, rather much higher than what bird would show, because of their high density and large body size. So yeah, and so far we are using generally two filters. One is the altitude filter, and the other is the density filter. Try to remove as many bats as possible. But I'll be honest, it's probably impossible to separate out all of them. But hopefully, what we have are in majority birds. And it's also that from the result that we think it's most likely what we have on the data I've shown are birds, because I didn't show the figure, but their flight directions is rather concentrated for several sites like Brisbane, Townsville, Cairns, Sydney. We think that the flying fox, although they also do this long distance migration, but probably it's they first of all don't fly that high, and their direction is probably more scattered than the birds. But it's definitely a question that we are still trying to work on in Australia.
Cool. Thanks. And yeah, maybe I have another question. Like, can you tell the size? I think maybe I heard that, like, maybe you can tell the size of the bird from the weather radar. And so, yeah, can you also separate between like smaller or larger shorebirds, for example?
So it's technically possible, but it's very challenging to do that. Because different size of objects would give you return different, let's say, the amount of energy of echoes back to the radar. And with the more advanced radars, such as now there are some radars that can generate pulses both on the horizontal and on the vertical plane, so it tells you the shape and the size of the target. So that's definitely possible. But what we are doing doesn't really involve that part, because we are working on like large-scale studies, and we try to know the density of birds on all of them are averaged. So yeah, but I think it's definitely possible, especially with smaller radars. And the radar, you know, there's one radar on top of the Fogelwatt building in Simpa, right? That radar, yeah, the bird scan radar, it can tells you the general category of birds by the wing flap pattern. For example, a passerine would their flight would be like flap for some time and then stop for a glide, while for shorebirds, I think it's constant flapping movement. So from the change of the energy in the radar signals, that we are able to tell like what possible group are the targets from, so, and the size as well. Yeah.
Cool. Yeah, thanks. Yeah, so there's another opportunity, maybe not weather radar, but these kind of smaller bird scan radars.
Yeah.
In studying shorebird movements. Really.
Definitely.
Yeah. Yeah. So yeah, I hope there will be more of these studies in the East Asian-Australasian Flyway. That would be great. Yes.
Yeah, true.
Yeah. And so maybe lastly, what will be your next step, like, to give us an idea of like where you will, are you working further on shorebirds or first on other birds? Yeah.
For me, what we are hoping to do next is to compare different sources of data. As I've shown that there are eBird data, like citizen science data, and we're also trying to include acoustic data now because it gives us a more precise idea of what's actually flying in the sky during that time. So with more data resources, we are able to be more confident to say to have an idea of the species that are migrating that we are seeing on the radar. So that's one thing. And another what I would be working on is I try to compare in Australia the bird movement patterns in let's say humid areas as well as dry areas, because in Australia there's a large arid inland part. So we are interested to see if the dry lands in Australia, the birds would be really chasing the rainfall in a certain degree. And as for shorebirds, I think it's really maybe optimistic now. I would look into the broom radar data in the future, and maybe there's some case studies available in China, such as for the Asian dunwitchers because they form a large flock and there's a radar nearby. So maybe that's a good opportunity as well. Yeah.
Oh, cool. Thanks. Danny has a question.
Long ago in 1994, I joined a Swedish-Russian expedition in the Arctic. Thomas Allistam was using radar to detect birds migrating over, and he had a team of bird watchers outside his radar station, and he'd say, "There's a flock of birds at this bearing and this altitude. Can you identify them for me?" And there were some very good bird watchers there, and hundreds of birds were identified. Are there any opportunities for real-time detection of birds and cooperation with bird watchers to identify them that you can see?
Yeah, I think it's definitely possible, especially if we can, like the laying study from 1985, if we can actually go to the radar station and look at the screen and say that there's a flock of birds, we see them on the radar, and can we see it on the beach, on the Broome Observatory, or somewhere near that. But if we are looking at the data that I have, it's always it's really up to date, but you can only say it the next day. So that's probably not possible to do a real-time comparison. But if we can, visit the radar station and do something similar to what Lane did like almost 40 years ago, then I think it's definitely possible. Especially with the Broome radar now being upgraded to Doppler radar, we can get more details out of it.
Yeah, sounds like fun.
Yeah.
Nice. Yeah. So with this note, I will end the webinar. Thanks again for coming, Xu. Thanks for your really nice talk and great work. And so there are also some thanks on the chat. You can read it. Thanks everyone for joining. Bye. See you next year.
Thanks. Yeah. Bye.